All right, guys, this is your first lesson for Chapter 3, our second unit. We're going to look at powers and exponents, and we're going to start by using exponents to describe numbers. So the first couple things that we need to look at are some keywords. So we are going to know what a power is, what a base is, and what an exponent is by the end of this lesson. And given any example, you should be able to recognize those three different components. We're also going to look at different diagrams that represent square powers and cube powers. And we're going to represent powers as multiplication, repeated multiplication, or we're going to use repeated multiplication and then represent it as a single power. So those are the kind of the 3 or 4 main things that we're going to be investigating today. So your first example, we have an example of a power. This is 4 to the power 2, or we could say it as 4 squared. And so when we look at this full example altogether is a power. And so a power is any expression so remembering that expressions are not equations, they don't have an equal sign, but they could have different operations like addition, subtraction, multiplication, division. So a power is an expression that is made up of a base and an exponent. So that means this whole thing together represents the power. So then the other two pieces we need to look at are the base and the exponent. And so the base is the part of the power that is being repeated. And so in this case, our 4 is what's being repeated. And then the other component is the exponent. And the exponent tells us how many times the base is repeated. So in this case, the base is going to be repeated twice, and so it's going to be squared. So let's look at a couple examples. So here we have an expression 5 to the power of 3. So in this case, the base is 5, and so the power is 5 to the power 3. Or we could say that it is 5 cubed, and the exponent is 3. In our second example, we have 7 to the power 4. So our base is 7, and the power is 7 to the power of 4. We don't really have a second way of saying this one. And so in this example, the exponent is 4. So we would repeat the 7 4 times. So 7 times 7 times 7 times 7. Okay, hopefully so far so good. So now we're going to look at visual representations of squares and cubes. And so hopefully you remember a couple days ago when we talked about perfect squares and we talked about perfect cubes, and we said what makes something a perfect square, and we said that it has whole number or rational number side lengths. And so we're talking about the same sort of thing here. We're talking about perfect squares. And so we know that they're perfect squares because they have whole number side lengths, and both side lengths are the same. And so this diagram is representing 3 squared. It's a length of 3 in the shape of a square. So this picture represents 3 squared, or 3 to the power of 2, because it's 2-dimensional. When we look at B, we have a cube, and we have a length of 2, a width of 2, and a height of 2. And so we have a figure that is 2 by 2 by 2, or 2 to the power of 3, 2 cubed. And the shape is a cube, right? So these last two, I want you to give those a try. I am going to double check them with you in class tomorrow. Okay, so when we have repeated multiplication, what that means is the same base multiplied many times. So basically anything more than, you have that base more than once is repeated multiplication. So in this case, if we remember, the 7 is our base, the 5 is our exponent, and the exponent tells us how many times that base has been multiplied together. So this is not telling us to go 7 times 5. If we wanted to say 7 times 5, that was how we would write it. This is saying we are going 7 times 7 times 7 times 7 times 7, 1, 2, 3, 4, 5 times. Okay? And the way that we know that these represent the same thing is we can double check in our calculator. So if in my calculator I type 7, and then you're probably going to need to find a button that looks like a little up arrow, and then 5, or if I go 7 times 7 times 7 times 7 times 7, I should get the same value either way. And so hopefully you see that once you start getting up into a 5th power, your numbers get large pretty fast. And this gives us 16,807. And if I type 7 to the power of 5, I get the same thing. So we have 2 more examples that we're going to write as repeated multiplication. And yes, I do want you doing this step so you get into this habit of what does repeated multiplication actually mean. And so we have a base of 3, and the exponent is 6. So that's telling me that the base of 3 gets repeated 6 times. Okay, 1, 2, 3, 4, 5, 6. And the way that we could double check that is I could type that in my calculator, or I could type 3 up arrow 6, and we should get the same answer both ways. And so for 3 to the 6, or 3 times 3 times 3 times 3 times 3 times 3, we would get 729 as our answer. All right, last example, we have 5 to the power of 3, or 5 cubed. So this is going to be one of those values that we had on our cheat sheet of the perfect cubes. And this is telling us to go 5 times 5 times 5. And that's 125. Same thing if you typed in 5. You might actually have a cubed button on your calculator, or 5 up arrow 3. Either way, you would get 125. Okay, these last 2 examples are going the other way. And so if you remember what we said, what the base is the value being repeated. And so in this case, what we have repeated is the 2. So our 2 is our base. And then the exponent tells us how many times it's been multiplied. 1, 2, 3, 4, 5. So we have 2 to the power 5. And if we weren't sure if this was correct, we would again put both into our calculator, and we should get the same value. The next example, we have 4s being repeated. And sorry, it kind of cramped in your notes there. But we have a base of 4, and it's being repeated 1, 2, 3, 4, 5, 6, 7 times. So we have 4 to the power of 7. Again, to double check, type both values in your calculator, and you should get the same answer. If you don't, you've probably either chosen an incorrect base, or maybe you didn't count very accurately for your exponent. All right, last example. This one's a nice, quick little video. Is 10 to the power of 3 equal to, so does it have the same value as 3 to the power of 10? I would like you to come up with 2 or 3 points that help you say, yes, they are the same, and this is why, or no, they're not the same, and this is why. And we are going to start tomorrow's class with a discussion. Thanks, guys.